Okay, our last section this week is 6.3. In 6.3 we're going to be looking at some exponential functions, which we got to look at a lot last year. But we didn't look at them this way. We just did a lot of algebra with them. There've been a lot of talk in the world about exponential functions here recently, so hopefully this kind of hits home for you. First thing I would have you do here is just to kind of refresh your memory on some of the exponent rules. Do these rules look familiar to you? Let's see if you remember them, okay? When I am multiplying and I have the same base, so 3 is the base, do you remember what I do with the exponents? I add them. So I'm going to keep the base the same and I'm going to add the exponents. Anything to the 0 power is 1. Doesn't matter if it's an x to the 0 or a number to the 0, if it's positive or negative, it doesn't matter. Okay, the negative power, negative exponent means that it's going to flip it. And so in this case, 5 becomes 1/5. Did a lot of that last semester. I hope that stuck with you. And then when I square this whole quantity, it squares everything inside. So the 3 gets squared and the x gets squared. Okay, I hope you remembered that you were squaring the 3 also. Alright, that is not what we're going to totally be looking at, but it will help us to get through some of this. Guys, I'm going to try a light here. It's going to get kind of wacky for a second. Keep the shadows down maybe. Alright, I'm going to look at the function y equals 6 to the x. First, I'd just like to make a little in-out table. Okay, so I'm going to do 6 to the negative 2. 6 to the negative 2 means I'm going to flip it over and make it 1 over 6 squared, which is 1/36. This is 6 to the negative 1, which means I flip it over and make it 1 over 6. 6 to the 0 is 1. 6 to the first is 6. And 6 squared is 36. That's going to be rough graphing some of those, but we're going to graph the middle for sure. If I go out here to negative 2, I'm at 1/36. Negative 1 is 1/6. 0, 1, and 1, 6, and that's about as good as that's going to get. When I graph this, do you remember what happens as x gets larger and larger? This is just going to shoot for the moon. And over here, is it ever going to become negative? Am I ever going to cross over that barrier? No, it's not going to cross over. It's just going to get ever so close, because it's going to be 1 over 6 to the third, 1 over 6 to the fourth. Never going to become negative. Okay? So our exponential function has this shape. Interesting. We're going to do that one more time, because I want us to see a trend that's happening here, okay? Y equals 3 to the x. I want you to try this one. Go ahead and hit pause, fill out the in-out table, and graph it. You should have 1 over 3 squared, 1 over 3, 1, 3 to the first, and 3 to the second. Okay? I'm going to go and graph those. Negative 2 is 1/9, negative 1, or 1/3 at negative 1, 0, 1, 1, 3, and 2, 9 is way up there. And it looks a lot like the other graph, doesn't it? All of our exponential functions look alike until we start moving some things around. But that's our basic form. Now I want you to notice something that was happening here with our graph of anything to the x. We call it a to the x. So when you're comparing those two graphs, something special was happening. Did you notice that there was a point in common? Yeah, this one. 0, 1 is always on there. 0, 1 is one of the points that's always contained. Did you notice what happened at 1? We had 1, 3, and we had 1, 6. Notice that it was 1 and then the base. So 1, and in this case the base is a. So 1a is one of our points. Did you notice what happened at negative 1? At -1, I had 1/3 and 1/6. So at -1, it took the base and flipped it over, right? Because that's our exponent rule. So -1 is at 1 over a. I need you to star, box, highlight, whatever it is you need to do, these 3 points for a to the x in your notes, okay? So that every time you graph one of these, I want you thinking about 0, 1, and -1 and what's happening there, okay? Let's see, this way. All right, let's take a look at just our plain old function a to the x. There he is. Aw, ain't it cute? Can you fill these in? Why don't you hit pause and see if you could fill those in. Okay, for the domain, see how it's going to continue going to the left and it's going to continue going to the right? Did you put -infinity to infinity? For the range, it's never going to cross over and become negative, so the range is always going to go from 0 to infinity. It's never going to actually hit 0 either, so parenthesis. X-intercepts, is it ever going to cross the x-axis? No. Y-intercept, does it cross the y-axis? Yes. Do you see where? At 1, every single time. It's going to cross the y-axis at 1, unless we move it, but this is just a to the x. Does it have a vertical asymptote? No, but it might appear that way sometimes. So if they get really, really steep, it looks like it is, but that's not what's happening there. It's just getting really, really steep. Does it have a horizontal asymptote? Yes, that's what's going on here. This is a horizontal asymptote at 0. On Pearson, you would call it y equals 0. Okay. Is this function 1 to 1? Remember from our last section? Does it pass the vertical line test? Yeah. Does it pass the horizontal line test? Yeah. Oh, dagnabbit. Me and lead. Okay. So that's our basic function, and that's how you're going to just kind of analyze them. But we need to do a whole lot more with them. So this is actually going to have 3 parts to it, and this was just looking at the function. All right, stay tuned for part 2.